Right, welcome to today's stream. It's going to be on gain on volumes and surface areas, just like yesterday, but the questions will be a bit more tricky at level 8 and 9 standard. So here's our first question. I haven't got a timer that I think is going to give you justice here, so what I'll do is I'll give you 3 minutes to see if you can get the first bit out and then 2 minutes to finish off. Okay, I'll start going through it after we've done the first 3 minutes. I'll do this bit and then leave you to try and finish off the rest. If you finish questions early, feel free to type in a numerical answer into the top chat. Okay, so just got myself a pen. Right, we've got a hemisphere, cylinder and a cone. We know the total length is L and we know the total volume of the solid. Now, a key piece of information to note is the hemisphere, cylinder and cone all have the same volume. Right, so if we call this R, then they all have the same radius. That radius is the same for cylinder as it is for the sphere, as it also is for the cone. And I'm going to call the height of my cylinder H, and I'm going to call this height of my, call that H1. I'm going to call this one H2. So therefore we know that the volume of this is equal to 4/3 pi r cubed times by a half, because it's only half a sphere. So that gives me 2/3 pi r cubed for the volume of the hemisphere. I'm just going to write this out, but you don't need this out for this part of the question. I know the volume of this is going to be pi r squared times by h1, and I know that the volume of this is going to be 1/3 the base area, which is pi r squared, times by the height H2. But because we're told they all have the same volume, we know they all have this volume here, 2/3 pi r cubed. So there's 3 lots of that. So therefore the total volume is equal to 3 times that is 2 pi r cubed. And that must be equal to 686 pi over 27. And if I divide throughout by pi, there we go, and divide throughout by 2, then I get r cubed will equal 343 over 27. Now I know the cube root of 343 is 7, and I know the cube root of 27 is 3. So r equals 7 over 3. Now, using all that information that I put on the screen, see if I can help you finish off the question in the next 2 minutes. Okay, so what we do know is we know that r equals 7/3. But we also know the volume up here, 2/3 pi r cubed, must equal this volume, must equal this volume. So we know that 2/3 pi r cubed must equal pi r squared h1. So we can cancel out a cube with the r squared, we can cancel out the pi's. So that leaves me that 2/3 of r will equal h1. And then if I use this volume here, I got 1/3 pi r squared h2 must equal 2/3 pi r cubed. And I can do the same thing. I can cancel out the thirds, I can cancel out the pi, and I can cancel out r squared. So I'm left with h2 equals 2r. So if we get rid of the fractions and times everything by 3, we can see that 2r here is equal to 3h1, and we can see that h2 times that by 3, we get 3h2 equals to 6r. So if we have the hemisphere at being r, okay, if we have the hemisphere at being r, what we're going to do, we need to just think about this. It's can be a little bit tricky to get these ratios right. So I've got 3h2. Sorry, I want to get what's going to be the simplest. I want to get the smallest one. So h1 is 2/3 of r, that's the smallest, and h2 is the biggest because it's 2r. So I want to make h1 my smallest. So I'm going to make h1 my smallest, and how are we going to do that? Let's just times that by, let's roll 2/3. 2/3 r, 2r equals. So therefore, the h1 and r is going to be in the ratio 3 to 2. And therefore, if they're in the ratio 3 to 2, we know that h2 is going to be equal to 2r. So if r is going to be in the ratio 3, then h2 will be in the ratio to 6, because it's double r. So we've got our hemisphere, which is going to be the radius, which is 3. h1 was my cylinder, which is the 2. And my cone here is equal to the 6. Okay, so work out what your ratio is on each thing. Because this is 2r to 3h1, therefore to make this equal, then r is 3 to h1's 2. Okay. Now, we want to calculate the total length of the solid. Now we know that the radius is equal to 7/3. Okay, we know that this is equal to 7/3, the radius. So if we know that the radius is equal to 7/3, then h1 will equal, if we take this, let's just write it below here, it makes more sense. h1 will equal 2/3 times by 7/3. And h2 will equal, I'm just going to rub that a little bit out. h2 will equal 2 times 7/3. So what we've got is our total length. We've got 7/3 of the radius plus 2/7, so that's going to be 14/9 plus 14/3. So let's make these all into ninths. So that's going to be 21/9 plus 14/9 plus times that by 3. I get 42/9. Add those all up and I get that as 77/9 as my total length. There we go. So a little bit more demanding than yesterday's lesson, as you can see already. Okay, let's try the next question. And this one, I'm just going to zoom in a bit there first. For you. Right, I'm going to give you 3 minutes to see how you get on with this. We may not do the whole of this question because it gets a bit repetitive, but we'll give you 3 minutes to have a go at this part of the question, these first two. If you get on to the second bit, all well and good. I'll give you 3 minutes and I'll go through that just to make sure you're on track. In case you can't see the shaded region easily, it's this region here. I'm just going to highlight it with a green highlighter. So it's just this region here. Okay, so it's a net, and that's the key thing you need to realise. So these sides will fold up to form a pyramid type shape. And so therefore this side is going to fold onto this side, so x is just equal to 10, so it's quite straightforward. So you don't need 1 dp. Well, I suppose you can put 10.0 if you really wanted to. Okay, but there's no need. We want to find the area of the shaded region, so we need to find this side here. So I'm going to call this side A. And I'm going to use this angle and this angle and this. So I'm going to use the sine rule. So we know that A over sine of 65 will equal 6 over sine of 40. So A will equal 6 over sine of 40 times by sine of 65. So we'll just grab our calculator because we can't do that in our head very easily. So 6 divided by sine of 40 times by the sine of 65. And we get 8.459. 59787 and so on. Okay, now we know that the area of this triangle is a half AB sine C. Because we know this angle here, because 40 per 65 is 105, so this must be 75. I can use this side as one side and this side as one side, and then you can use this in this formula. So if we do the area equals a half this length times this length, it's always the two lengths either side of the angle, 6 times 8.45 and all the other stuff, times sine of 75, and we want this other area here. Now we know x and we know a, and we got the angle 35, so we're going to be plus adding onto that a half times 10 times 8.45 and all the rest times what's that going to be, sine of 35. So we grab a calculator again, and I'm going to put that equals, so I've got that answer. And I'm then going to do 0.5 times 6 times the answer times sine of 75. Add on to that 0.5 times 10 times answer times sine of 35. And using the answer means I keep all the digits that I would have had in here. Okay, press equals and I get 48.77. And to one decimal place, that means I got 48.8 is my answer. Right, I'm just going to give you another 3 minutes to see how far you get into the rest. If you don't finish it off, don't worry, because things like the surface area of the pyramid is just finding out the other two areas, and it's just more of the same. Okay, I'll write in the answers for you to check. I may not show all the working for all of it. We'll see how we go for time. So 3 more minutes, because we've still got another 2 questions to have a go at. Okay, so let's have a look at y. Now we know that y is opposite the 75 and you've got the 40 opposite the 6. So to find out y, we can use y over sine of 75 is equal to the 6 over sine of 40. So y just equals 6 over sine of 40 times by sine of 75. I won't do all that on the calculator. It comes out to be about 9.016. So to one decimal place, it's 9.0. You just type this into the calculator as you see it on the screen. Now for z, okay, we've got z over here, and we know it's the same as this side here. Okay, so we can use the fact that we know that this is 10. That's x, and we know that side is 8.4 something. Okay, and then we've got this side, and we use cosine rule here. Okay, so we know that z squared, so this is also equal to z. So we know that z squared will equal 10 squared plus the 8.45 squared minus 2 times 10 times, I'm going to run out of space here, let's just give myself a bit more space. There we go, times 8.45 times cos of 35, and you just type all of that into your calculator and you get, I think it's about 32.95 and so on. Square root that, we get 5.74 and so on. And so therefore to one decimal place, z is 0.7. Now to find the angles, P, we're going to use the fact that we use the cosine rule here. So to find P, we've got y now, we've got that, so we can use the cosine rule here. We don't have an opposite pair, we need another angle to find out. We don't know this angle, so we use the cosine rule. So we know that cos of P, just rearrange it, is going to be equal to this side plus this side minus that side. So we're going to get 10 squared minus, plus 8 squared minus y, what was it, 9.01 and the rest squared, all over 2 times 10 times 8. We work that all out and we get 0.51 and the rest. And so P is inverse cos of that, and we get 58.87 and so on. So that's 58.9 degrees. And Q here, so we know this side, we know that side, and we know this side because it's going to be 8. So it's exactly the same type of question. It's a cosine rule question. I won't go through all of that, okay, because it just repeats this type of working. So do it exactly the same way, except where the 10 is, you're going to have the value of z, and where the 8 is, you're going to have the value of 6, and where the 9 is, you're going to have the value of 8, and similarly on the bottom, then work it all out. And we get Q is equal to 85.9 when you've worked it out. And to find the surface area, you've got to find the area of these two. So use the same formula as did here to find this triangle. Similarly, half 10 times 8 times sine of P, half of Z times 6 times sine of Q. Add them all up, and when you've finished, you should get 102.2 centimeters squared. Right, there we go. Something a bit more interesting, a bit more algebra on this one. Let's just zoom in this for you. Okay, and let's see if you can do this one in 3 minutes. A little trick is not to multiply out early and to look for common factors. Right, so on this question we want to write down a volume expression for the volume. Now we know the volume of a pyramid is a third. Actually, I'm just going to give myself a bit more space by zooming out. Zoom out. So we know the volume is equal to a third times the base area. So it's times 9 over x minus 3 times 2 over x plus 18. Times by the height, 4x over x minus 1. And we also know the volume of the cube is going to be, sorry, I need a plus there. We're going to add on the volume of the cube. So we're going to have plus, the volume of the cube is going to be 9 over x minus 3 again, times 2 over x plus 18 again, times by 4, just give myself a bit more space. It's not happening. So we're going to times by 4x over x minus 1 here, and you can see we've got a factor of 9 over x minus 3 and 2 over x minus 18. So let's take those two out. So 9 over x minus 3 times by 2 over x plus 18. And that leaves us 1/3 of all of this. So we got 4x over 3x minus 1. Multiply that by that. And we're left with this 4x over x minus 1 here. And so we need to times top and bottom this by 3 so we can add those two together. So we get 9 over x minus 3 times 2 over x plus 18. And I'm just going to, so 4 times top and bottom that by 3, so I get 4x plus I'm going to get 12x over 3x minus 1 over 3x minus 1. And just there's something not quite right here. I just made a mistake somewhere. I know what I've done. Sorry about that. I've just multiplied over here by the wrong thing. The height was this thing here. Had a feeling it was just something was not going right. That's the wrong thing here. Apologies. I'll just put the right thing in for you. It should be 6x minus x over x minus 1. And I'm going to put 6 minus x over x minus 1. I'm going to times top and bottom by 3. And so I'm going to get 18 minus 3x over the same thing. So we get 9 over x minus 3 times 2 over x plus 18 times 4x minus 3x is x plus 18 here over 3 open brackets x minus 1. And we see we've got an x minus 18 plus 18 here and x plus 18 here, so they can cancel. We've got 3 here that can cancel out with a 9 here. So that leaves me 6 over x minus 3 times by x minus 1. And the reason why I knew things were going wrong there is I just knew I had to get down to something cancelling and it wasn't happening. So that's why I knew I'd made a mistake. So I get 6 there, I get a minus 3 here, and I get a minus 1 here. Now I know the volume of the solid is equal to 1 centimetre cubed, so make that equal to 1. And so therefore 6 will equal x minus 3 times by x minus 1. So I get 6 equals x squared minus 4x plus 3. Take away the 6, I get x squared minus 4x minus 3. And I know it's not going to factorise. So I'm going to complete the square on this. So I get x minus 2 squared. I'm going to take away 4 and take away 3 to make it all balance up. That minus 4 cancels out the plus 4 that comes from here. And I need the minus 3 there. So I get x minus 2 all squared minus 7. So I get 7 equals x minus 2 all squared. Square root of that and then add on 2. And we know that x has got to be positive, so it must be 2 plus the square root of 7. Right, move on to the last question. Quite a marathon. This one is also another tricky one. There are no easy ones today. Okay, see how you get on in 3 minutes and see where you get to. Don't worry if you don't get this first time. Have a look at it. Have a look at my answer. And then see how you get on when you try and do it again in a week's time if you don't get it out. Okay, don't worry if you didn't get it out. Let's have a look at this question. Now, the key thing here is to recognize that you have similar shapes going on here. So we've got this triangle here, and we've got this length is 6, this length is 12, this length is x, and then we've got r down here. Okay, so therefore we can see that we can work out the scale factor of enlargement, because the whole length here is going to be 12 plus x, and the original length was 12. So the scale factor that we're dealing with here is 12 plus x over 12. So therefore r will equal 12 plus x over 12 times by 6. And which simplifies to 12 plus x over 2. Cancel the 6 out with the 12. We get 12 plus x over 2. Now we know that pi RL therefore will equal, the radius here is going to be 12 plus x. So we've got pi times 12 plus x over 2 times the whole length L, which is going to be times by another 12 plus x, and that gives you the curved surface area of this shape. But we've been given this shape, this frustum. Okay, so we know the frustum 728 pi will equal all of this minus the top bit. Now notice I'm leaving the 2 to make life a bit easier for myself in a minute. And I'm going to take away the top bit, which is going to be 12 times 6, 72 times by pi. Gives you pi RL for this little top bit here. So that gives me 72 pi there. Now if I times that by 2, I get rid of the fraction. So that gives me 1456 pi here equals pi times, I'm going to multiply this out now while I'm here. So I'm just going to rub that out and multiply this all out. I do need that bracket because I've got a pi there. So I've got x times x is x squared. Notice I've already times by the 2, so I don't need to worry about that. So I've got x times x squared. 12 and x gives me 24x. 12 times 12 is 144. And if I times this bit by 2, I need to times this bit by 2 as well. Common mistake will be to forget this. So that's 144 pi here. And we can see we can cancel out the pi's throughout. So I've rubbed that out, sorry. So cancel out the pi there, there, and there. So therefore 1456 will equal x squared plus 24x. And I've got plus 144 minus 144, so I don't need any more than that. So I get x squared plus 24x minus 1456. Now, 1456, and if it's a non-calculated question, you want to factorize this, okay, then you need to prime factorize. Is probably going to be the way you go about doing this. So I'm just trying to think. Okay, here we go. We've got 2, and we've got 728. We go 2, and we've got 3642, and we've got 182. 2 to 91, then that's 7 and 13. And you have to try and think to yourselves what kind of factors might work to give me this, 24. And you just try some of these. So you try 2, 2 gives you 4, 7's 28, 2, 2 and 13, that will give you 52. And you can see that these differ by 24. So that's going to be my factors. If you're in a calculator paper, don't waste your time doing this. Use the quadratic formula. It'll save you a lot of time. So because I've done this already, so I know which ones I'm going to pick out to give me my factors. So I'm going to get x minus 28, and I'm going to get x plus 52. So therefore, because x must be a positive value, I know that x is equal to 28. And because x is 28, 12 plus 28 gives me 40, divided by 2, r is equal to 20. Right, let's just go back, and we want to find the angle A at the centre of the sector. So my centre of the sector, I've got theta over 360 must equal times by this area here is going to be equal to the area of the whole of this thing here. So that's going to be equal to, let me just think, it's going to be equal to 2 times pi times that length there, which we know to be 40. And that must also equal pi r L. Now we know L is equal to 40 here, and we know that R is equal to 20. So this whole length is 40 because we've got 12 plus x. So we can do some cancelling, do some more cancelling, leave me 10, cancel out the pi's, and something, I've made a mistake somewhere. What have I done? Oh yeah, I'm doing area. Sorry, I've done circumference there and I want to do area. I knew it wasn't going right because I was going to get a massive angle. Let's just write this in, and it's pi r squared, so it's pi times 40 squared. So I'm going to cancel one of my squares out with the 40 there, and then I can cancel 20 out with 40 to leave me just 2 there. Cancel out my pi's, so I've got theta over 360 times 2 equals 1. So therefore, times by 360 divided by 2, theta must equal 180 degrees. All right, so there you go. Easy to spot my mistake. I was coming out of an angle that was going to be bigger than 360, so I knew I'd gone wrong. So therefore, that is how I was able to realise I'd used circumference rather than area, and that's how you get to the right answer. I hope that was helpful. If you need more help, you can always go and visit my website. This is just a screenshot of it for you. It's mathslessons.net. If you want to get extra help, you can go there. Thank you for listening.